Hello everyone, welcome to the video series on data science and machine learning with Python programming language, and in this particular video we will extend our understanding of NumPy. This is part 2 of the NumPy. If you haven't looked into my part 1, I will highly recommend you to go ahead and look into part 1. I'll provide the link in the description section. So let's go ahead and start the part 2 of NumPy. In this particular video we will talk about 3 specific things. They are how to update data in an existing NumPy array, how to slice NumPy arrays, as well as how to split NumPy arrays horizontally as well as vertically. So let's go ahead and start. I am using a Jupyter notebook. You can find these notebooks in my GitHub page. Okay, so let's go ahead and start. To use the NumPy, you know that I will have to import NumPy as NP. Now before we go ahead and start using NumPy, let's do a small recap. There are 2 specific reasons for using NumPy. Reason number 1, they have effective storage mechanism in memory, so it takes less amount of memory as compared to Python list. And the second reason is that they are meant for mathematical computation, and doing mathematics is extremely easy with NumPy. That's why we are preferring NumPy as compared to Python list. Okay, so now let's talk about how to update an existing NumPy array. Let me create a NumPy array using .array function. I am providing 1, 2, 3, 4, 5, and this is how my NumPy array will look like. Now the first thing first, just like Python list or for that matter any other programming language, we can use the index on arrays to change the values. So if I say ARR2 equal to 300, which means that the element at index 2 should be changed to 300, and it will change to 300. You can see that 300 is there at index 2. One thing you should take care while updating NumPy array is that unlike Python list, you cannot provide some other data type in NumPy array. It will give you an error because NumPy arrays are of homogeneous type. Please go ahead and see my first video to understand why NumPy arrays are homogeneous in nature. Okay. Now this is a single changing of an element using the index. What if we want to change the complete array, complete NumPy array? One of the most widely used function is numpy.put. So here is how we can use the put function. It takes 3 arguments. The first argument is the NumPy array itself. The second argument is the list of indexes that needs to be changed. The third argument is list of new value that needs to be updated. One good thing about numpy.put function is that it changes the arrays in place so that you don't need to create a new NumPy array out of an existing NumPy array. Let's go ahead and see it with a very simple example. I am having this array called 1, 2, 3, 4, 5, 6, and I am changing the index number 0, 1, 2 with 10, 20, 30. If I go ahead and do that, you can see that index number 0, 1 and 2 is changed to 10, 20 and 30. So now you might have guessed that to change all the elements I have to provide all the index 0, 1, 2, 3 and 4 and all the new values like 10, 20, 30, 40, 50 and 60. And this is how my new array looks like. Now similar to numpy.fill function, we can provide a single value that will be put into all the indexes which is being specified over here. In here what I am doing that I am providing the array index at 0, 1, 2, 3, 4 and I am giving 1001. This means that all the indexes 0, 1, 2, 3 and 4 will be changed to 1001. Now what will happen if I provide less number of elements as compared to number of indexes which I have provided? For example, in here I am providing index 0, 1, 2, 3 and 4 while I am providing only 2 values 11 and 22. Any guess what will happen? Well, it will not give me an error. What it will do that it will loop through all these elements values until the index is completed. So 0 will be 11, 1 will be 22, then again 2 will be 11, 3 will be 22, again 4 will be 11. So that's the way NumPy put function work. It is very important to understand how this kind of permutation combination work, because this is what you are going to use when you want to update an existing NumPy array. Now not only that, you can use range and for loop to find the indexes. For example, I can say numpy.put the array, I can say range 5. You know what range that it will generate a number excluding 5. So it will generate a number 0, 1, 2, 3, 4, 5. And all the new numbers called 1, 2, 3, 4 and 5. If I go ahead and do that, you can see that my array is reset to 1, 2, 3, 4 and 5. Now similar to some computation in a list array, we can do the same thing in NumPy put function. In here I am providing an index for the value which is divisible by 2. So what I am doing is that for index value is in enumerator array if value mod 2 is equal to 0. You know what the enumerator does, it gives me counter also along with the value. I'll change the index which is divisible by 2. But I am providing more values over here. Of course, not all of them are divisible by 2. So what will happen? If you go ahead and see, we can see that the first true value which is divisible by 2 will be changed to 11 and second will be changed to 12. This is the way NumPy put function works. Now we have seen the NumPy put function for single dimension array. Let's go ahead and see it for n dimension array. So let me create a 2-dimension array with 5 rows and 4 columns. So there is no straightforward way of putting the element into array in multiple dimension. What you need to do is that you need to create a single dimension array out of the multiple dimension array. You can do the same by calling the flatten function. It will give you a single dimension array, and once you get the flattened array, you can put the range of elements that needs to be there. In here I am providing index also as range 20, value also as range 20. So what it will do is that it will give me array 0 to 19, and to get back the original array we need to call the reshape function with the original dimension 5, 4, and here is how we get the original dimension. So this is the way we will change our array NumPy arrays using put function for the single dimension arrays as well as for multiple dimension arrays. Now let's talk about slicing NumPy arrays. Slicing is very important. It works very similar to the way it works in list, because when you are extracting some information from NumPy array, especially when the information is extracted from millions of elements, it is extremely important. So let's see how we can use the slicing. So let's first concentrate on slicing one-dimension array. I have created an array and I am printing the array. I can print the array as ARR, and you can see that 1, 2, 3, 4, 5, 6 is being displayed over here. Now if I give a subscript with colon, this also means everything has to be displayed. Now the colon has a special meaning in slicing. It is called a inclusive exclusive. You can call it a kind of operator or range operator. So if I say ARR 0, 6, which means that include index 0 but don't include index 6. That means give me a range from 0 to 5. So if I go ahead and use this, I'll get complete element because there is no index called 6 and it is giving me till 5. One important thing to understand is that 0 is the first element and -1 is the last element. So if I say 0, it will give me 1 and -1 will give me 6. Similarly, -2 will be 1 before the last element, which will be 5. Similarly, if I want to get the data from index 1 to 5th but excluding 5th, remember this is inclusive exclusive, including 1, excluding 5. It will give me 2, 3, 4, 5, which is index 1, 2, 2, 3, 4. Okay. And if I don't know what is the length of the array index, I can just say 1 to -1. It will give but -1, but the last element, because we know that this is inclusive exclusive. And if I really don't know what is the number of elements after this, if I just don't give anything, it will give me rest of the element. So that's the way slicing of one-dimensional array works. Now let's talk about 2D array. Let's create a 2D array with 5, 4, and these are 5 rows and 4 columns. Okay, so when we are slicing 2D arrays, the array, the dimensions are separated by comma. Again, in here also, if I just say a colon, it means everything. Now let me put some data into it using the numpy.put function, and I'm giving the range. Now I want to print all rows, so I'll say colon, comma, colon, which means that all rows and all columns. Similarly, if I say 1, 1, which means that one row, one column, which will be 5. So this will be 0th row, this will be first row, this will be first column, and this will be the element. Okay. Now the inclusive exclusive range which we talked about in single dimension array is applicable for multiple dimension also, which means that if I say ARR 0 to 3 and 0, 1, it means that in the rows give me 0, 1 and 2 rows and give me only 0th column. So it gives me 0, 1, 2 row and only 0th column. If I want to add one more column, I can say that give me 0 and first column with 0, 1, 2, 3 row. Sorry, 0, 1, 2 row. So including 0, excluding 3, including 0, excluding 2. Okay. So if you don't specify the higher dimension, if you don't specify comma separated thing, it will consider everything from that dimension. For example, in here I am saying a double dimension array 0 to 3, which means give me row number 0, 1 and 2, but I am not specifying column, which means that give me all columns. It is similar to providing a colon, comma separated colon, which means all columns. So these two are same. Now let's talk about 3-dimensional array. In here I have created a 3D array, which you can see over here. As the dimension increase, the comma separated colon increases. So first dimension, second dimension, third dimension. So everything has to be displayed. In here I am saying that display everything from first dimension, display everything from second dimension, but from the third dimension display only 0th element, and it will give me this. So that's the way we do slicing in NumPy arrays. Now let's talk about splitting NumPy arrays horizontally and vertically. Let me create a NumPy array, and this is the NumPy array I have created with 5 into 4. Okay. Now if I want to split row wise or column wise, if we want to split row wise, we will use numpy.split function. Now here is how we can use it. When we say split numpy.split function, we provide the array and we provide a list and we provide some numbers in that particular list. Let's understand what is the meaning of this number. So if I provide 1, this means that give me splitting of one row and rest as it is, which means that it will split the first row and rest as it is, which means that if I say split 0, it will give me first row, and if I say split 1, it will give me rest of the rows. Now you can see that 4 rows are there in split 1 and 0th row is there in 0th element. Now if I provide two parameters called 1, 2 in split, what this does is that it says that split and give me first row separately, second row separately, and rest of the row in a separate way. So if I do this, if I say split, you can see that the first row is splitted, second row is splitted, and rest of the rows are there in the another element. So if I go ahead and print that, you will get the same information. Now what will happen if I provide let's say non-symmetric input like 1, 4 over here? What will happen? So here what I am saying that give me first row by splitting the first row, and then split second, third and fourth row, and then split rest of the rows. So it is splitted the first row, then second, third, fourth row, and then last row, which is the only row left. So split 0 will be first row, split 1 will be second, third and fourth row, split 2 will be the rest of the rows. That's the way we use split function to split things row wise. Now let's talk about column wise split. The usage is extremely similar. The only thing is that we use hsplit instead of split function. So if I say split hsplit as 1, which means that split one column and give me rest of the column. So split 0 will be first column, hsplit 1 will be rest of the column. Similarly, if I say hsplit 1, 2, what will happen is that first column will be splitted, second column will be splitted, and rest of the column will remain same. So hsplit 0 will be first column, 1 will be second column, and 2 will be rest of the column that is there in that NumPy array. Now let's talk about asymmetric one, like I say hsplit 1, 3. What will happen over here is that the first column will be splitted, second and third column will be splitted, and rest of the column will be splitted. So hsplit 0 will be first column, hsplit 1 will be second and third column, and hsplit 2 will be rest of the column. So that's the way we do horizontal and vertical splitting of NumPy arrays. So that's all about this particular video, guys. I hope I was able to explain things in the easiest possible way. Thanks a lot, guys. Thanks for watching. Please take a moment to like, comment, share and subscribe. Thank you. Thanks a lot.